For question number 2, this is going to be kind of similar. F of 0 is going to be 2 times 3 to the 0, which is really just 2 times 1, which is 2. So f of 0 is 2. F of 1 is 2 times 3 to the first. 2 times 3 is 6. And what I can see already is this is exponential, and I'm multiplying by 3. So without doing too much work, I know f of 2 is going to be 18. F of 3 is going to be, well, 18 times 3 is, I believe, 54. Okay, going in the other direction, I'm going to be dividing by 3, which is the same as multiplying by 1/3. So this is going to be 2/3. Divide by 3, which is the same as taking my 2/3 and multiplying by 1/3, so that's 2/9. Divide by 3, same as taking my 2/9 and multiplying by 1/3, so that's 2/27. And I could check that out. F of -1 is 2 times 3 to the -1, which is 2 times 1/3, which is 2/3, which is what we have. Okay, so when we go to plot these points, we have 0, 2. We have 1 and 6. We have 2 and 18 already off the page. We have -1 and 2/3, -2 and 2/9, -3 and teeny number. So we're again going to have a graph that looks like this. So as x gets larger, y gets larger. Y gets larger. Y gets larger, really large. Exclamation point. As x gets more and more negative, y gets really close to 0. And will the y ever be equal to 0? No, and that's because we have a horizontal asymptote. The other thing I want to notice is we've got some significant numbers here. 2, it turns out, is the y-intercept. We can see that. 2 is the y-intercept. And the significance of 3 is our multiplier. So if we look at question number 1, the same thing is true. 3 is our y-intercept, and 2 is our multiplier. So when we have a function, I'm going to say an exponential function is going to look like this. It's always going to be the y-intercept times the multiplier, right? What we multiply y by to the x for right now.